Unit 6, Part 7, I can factor special case polynomials. So first off, you do have this resource. It is your perfect square chart. So we are going to be referencing this throughout this lesson. First type of special case polynomial we are going to work with is the difference of two squares. So difference means subtraction. So if we look at our first problem, we have x squared minus 36. If we look at the next one, 4x squared minus 64. So there's going to be subtraction. And then two squares means that the values are all going to be perfect squares. So x squared is a perfect square because it's x times x. It's a square. Also, it has that one value in front, which is a perfect square, 1 times 1. And then if you just look at your chart, you can see all those perfect squares on there. We've got 1, we've got 6, we had 4, or I'm sorry, 36, we had 4. So all of these values are perfect squares, which means that they factor nicely into two numbers that are the same. So if we look at our first problem, 1x squared minus 36, you can also notice that there is no middle term. We just have that x squared and then minus 36. This value in the middle is 0. There's nothing in the middle there. So those two terms are going to need to add up to 0. They're going to cancel each other out. So if we think about that, x squared is made by doing x times x. And then 36, we're going to use the fact that 36 is a perfect square. So we're going to look at 36, and 36 is being made by 6 times 6. That's what 6 squared means, 6 times 6. So we're going to put a 6 and a 6, but we do need to note that it is negative 36, so one of these 6's has to be negative to make that negative 36. So if we fill in the missing blanks, we'd get x times negative 6, which is negative 6x. And then we'd have 6 times x, which is 6x. So you can see that 6x and then that negative 6x added together would make that 0, leaving us with just x squared and negative 36. So our factors are going to be x plus 6 and x minus 6. All right, so let's try this next one, and I want to see if you can notice this pattern that is happening. So in our next example, we have 4x squared minus 64. Still that middle term is 0. There is no middle value, so we're hoping to see that cancellation again. All right, so 4x squared, we can go to our perfect square chart, and we can see that 4 here is 2 times 2. So we're going to use that information. We're going to say 2x and 2x would make that 4x squared. And then if we look at 64, we can go over to our perfect squares chart, and we have 64 is 8 times 8. So we'll put that off to the side. And remember, 1 does need to be made negative to make it negative 64. So then if we finish off that multiplication, we have 2x minus 8, or times negative 8, excuse me, is negative 16x. And then 2x times positive 8 is positive 16x. And 16 minus 16 does make that 0 in the middle, leaving us with that 4x squared minus 64. So the factors here would be 2x plus 8 and 2x minus 8. So the reason why this is a special case is that the factors are going to be the same. You can see that they're the same, except for one is adding and one is subtracting. So that's the only difference between the two parentheses. Everything else is the same. It's just one is an addition sign and one is a subtraction sign. So if we look at problem 1 here, we have x squared minus 81. So this is going to follow this example here. So we'd have x plus a number and then x minus a number. And that number is going to be that square root of 81. So what number times itself gives us 81? Well, we can look at our square root chart, and we can see it's right here. Be that 9 times 9 would give us 81. So x plus 9, x minus 9. And then that same pattern would happen over here. We'd have 9x squared minus 25. So we'll take the square root of 9, which would give us 3. So we'd have 3x and 3x plus a number minus a number. And I want you to figure out what that final number is going to be. Make sure you use that 25 value to find that. All right, so now sometimes, just like in factoring trinomials, we need to factor out a value first. So if you look here, 98 and 200, if we look at our square root chart, we don't see 98 or 200 on this chart at all. They aren't on the values. So what we need to do is we need to factor out the greatest common factor first, which would be 2. We can divide both of these by 2. 98 divided by 2 is 49. Keep that x squared with it. And then 200 divided by 2 is 100. So we factored out that 2. So that 2 is going to come out here in front of our factors. And now 49x squared minus 100, if we put that into our box, we need that 0 value there. This is just like that pattern, so we'll take that square root of 49, which is 7. 7 squared is 49, so 7x and 7x. And then 100 is 10 times 10. Make sure one of those is negative. And if you want to test it out to make sure it's good, you can just finish that multiplication. Negative 70x, positive 70x would cancel out. So we have that 7x plus 10 and the 7x minus 10. So using that pattern, I want you to try problem number 3 on your own. Just try it out. Make sure you factor out that value first. Find out what value needs to be factored out first, and then use that difference of 2 squares pattern to figure that problem out. All right, now we are going to move into a different type of special case, which is called the perfect square trinomial. Perfect square trinomial is going to be similar to the difference of 2 squares in that the factors are going to be the same, except for now we're not going to have a plus and a minus difference. It's just going to be the same number. So let's just jump in and you'll see what I'm talking about. So we have 16x squared minus 40x plus 25. And we are still going to be using those perfect squares. So the key to knowing if it's going to be a perfect square trinomial is looking at that a value and that c value. 16 and 25 are perfect squares. If we look on our perfect square chart, we see 16 and we see 25. Those are perfect squares. So that's a key indicator that we might have a perfect square trinomial. So if I look, 16 is 4 times 4. So to get that x squared, we'll do 4x times 4x. And then 25 is 5 times 5. Now, I see that this middle number is negative, so I'm going to make it negative 5 times negative 5. And then let's check to see if this does add up to that negative 40. So if we do 4x times negative 5, we get negative 20x. And then we also do 4x times negative 5, which gives us negative 20x. And then we can see that negative 20 plus negative 20 would be that negative 40. So our factors are 4x minus 5 and 4x minus 5. So you can see that they are exactly the same, which means we can actually write it as just 4x minus 5 squared. So to simplify that, we would just use that power of 2 to indicate that both factors are exactly the same when we factor that trinomial. So let's try that again with a new problem. We have 9x squared plus 30x plus 25. So I can see right now that that 9 and 25, those are perfect squares. We can see it on our chart, 9 and 25, perfect squares. So we use our little table for right now, 9x squared, 30x, and 25. So 9 is equal to 3 times 3. X is x times x. And then 25 is 5 times 5. All values are positive, so I'm going to leave them as positive. And let's check to make sure that works out. We've got 3x times 5, which is 15x. And then we have 3x times 5, which is also 15x. And then 15 plus 15 does make that 30x. So we have 3x plus 5, 3x plus 5. Again, they're exactly the same, so we just rewrite that as 3x plus 5 squared. All right, so problems 4 and 5 follow that same pattern of finding the square root of your A and your C. So let's just do one without the box, just to get the feel of how that would look. So the square root of 4 is 2, so we'd have 2x, and then the square root of 1 is 1. And now we do need to make note that this middle number is very important, that -4. So if that value is negative, we are going to put a minus here in the middle. If that number is positive, we are going to put a plus sign there in the middle. So we have 2x minus 1. And very important, this 4, you can see, does need to be able to be made by doing 2 times the two values here. So 2 times 1. 2 times 1 is 2, times 2 is 4. And you can look up here and we can see that 4 and 5 are our values, our square roots, because we did the square root of 16, which is 4, square root of 25, which is 5. We do 4 times 5, we get 20. If we multiply that by 2, we get 40. So that is the pattern there for that middle number. If that middle number doesn't align with that pattern, it isn't actually a perfect square trinomial. So it's always good to check and make sure that you're doing it correctly. So now let's go through number 5 together. We have 100x squared. So we're going to take the square root of 100, and that'll be 10. And then 81, we'll take the square root of 81, which is 9. We'll double check for that middle number. That middle number should be 2 times 9 times 10. 9 times 10 is 90. 90 times 2 does give us that 180. So then we can take that 10x. All of them are positive, so we'll do plus 9. 10 and 9 make that perfect square trinomial. So here's 4 practice problems for you to try on your own, and then there is the check-in and then the quiz on Schoology. Now, these can be factored using your normal factoring methods. However, sometimes it can just make it a little bit faster if you pick up on the special case. But if you're getting just like confused on the special case, just go back to the way you were factoring them in topic 2 and use that factoring method, and it'll work just the same as it does for this guy. All right, that's all your notes, so go ahead and jump into this practice.